Alright, in this video I'm going to be looking at the big picture, and I want to focus right now on our trig ratios. So if someone asks you to find the cosine of 120 degrees, you should be able to do that with no problem using one of 3 or 4 different methods. So I'm going to talk about kind of where we've been and kind of put it all together. And when we get to the unit circle, I hope to convince you that the unit circle tends to be the best way long term to remember your trig ratios. But all of them are valid. Alright, so let's look at 1 point. Well, we started with our definition in 1.3. And so if we have a point on the terminal side of an angle theta in standard position, so this is the origin of the xy axis, and our theta is here. Here's our point on the circle. And so we have our 6 trigonometric ratios. Easy for me to say. Alright, so if we were going to find all those here, we would want to first find r. And basically all you would really need to do is make a right triangle here, and you could figure out what r is. But we can just use our little formula here. It's going to be the square root of x, which is 3 squared, plus y squared, that's going to be negative 4. So we're going to get the square root of 9 plus 16, or the square root of 25, which is 5. So we know that x is 3, y is negative 4, and r is 5. So the sine of our theta here is y over r, which is negative 4 over 5. Cosine of theta is x over r, that's going to be 3 over 5. The tangent of theta is y over x, and let's see, y here is negative 4, and x is 3. Now you could do the same thing with these other ratios, but notice these are the reciprocals, or what we learn later on is these are the reciprocals of what we have here. So this would be negative 5/4, this would be 5/3, and this would be negative 3/4. Now, I actually like to write these a little differently to help me remember them. I normally write sine of theta is y over r, cosine of theta is x over r, and the tangent of theta we know is sine over cosine. So if you put y over r divided by x over r, I could put a big division symbol here, it ends up being y over x. And then our reciprocal ratios go here. So sine goes with cosecant, and cosine goes with secant. The way I remember that is you have a SC, CS. They don't match. They're not both C's or both S's. And so here we're just going to flip this one. We get r over y. Here we're going to flip that one. We get r over x. And of course, cotangent theta is the reciprocal of what we have here, so x over y. So that's the way I like to remember those ratios. All right, so the next thing we moved on, not necessarily exactly in this order, but we got to section 2.1, and we focused on right triangles, and these were how our ratios were defined. We talked in terms of the sides of the triangle. Now some of you may be using SOHCAHTOA. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. So again, this is opposite over hypotenuse, adjacent over hypotenuse, and then if you put sine over cosine, you get tangent, and you have opposite over adjacent. And then when you flip these three, you get these three here. And so that's the way that I remember those. All right, so now let's move on to our special triangles, which we use now as we start learning our special angles that we use throughout trigonometry. Actually, let me just move this a little more. All right. So this is the special 45, 90 degree triangle. And we use that to find the sine and all the other trig ratios for 45 degrees. So the sine of 45 degrees, we know sine is opposite, which is 1, over hypotenuse, which is square root of 2. And we multiply each of those numerator and denominator by square root of 2. We end up with the square root of 2 over 2. And so that's the sine of 45 degrees. Now we could find the cosine and all the other ratios, but for now I'm just going to find that one. Notice in the right triangle with 45 degree angles, your two sides are 1 and your hypotenuse is the square root of 2. You should know this triangle by heart. Same thing with this one here. Notice in the 30, 60, 90 degree triangle, right triangle, the shortest side is 1, which is half of the hypotenuse. Or you might just start with the hypotenuse being 2, and the shortest side is half of that. And the other side is the square root of 3. All right, so sine of 30 degrees would be opposite over hypotenuse, which is 1 over the hypotenuse, which is 2, so 1/2. And then the sine of 60 degrees, so now we're here, is opposite over hypotenuse, so the opposite side is square root of 3 over the hypotenuse, which is 2. All right, so there's the sine of 60 degrees. All right, let's move on. So now we're ready to put together a table, which is what you did earlier on in the semester, or in, not really a semester, just a couple weeks here. So you can use those two triangles to get all these measures here. And in fact, I'm going to show you how you can get the table quite quickly. Although we're going to use the reciprocal identities that we learned in section 1.4 and the cofunction identities that we learned in 2.1. So let's go ahead and cover this up. And you know what, let me just go back a little bit. Not working very well. Let's try something a little different. There we go. We don't want to cheat. So let me show you how quickly you can put this together. All right, so I already put in the ones that we just got using those two special triangles. Now, we know that the cosine of, well, let's say the sine of 30 degrees is equal to the cosine of 60 degrees. So this should be a half. And the cosine of 30 degrees should equal the cosine of 60 degrees, which was square root of 3 over 2. So these are basically opposite for 30 degrees and 60 degrees. Notice 30 and 60 add up to 90. Now for the cosine of theta, it turns out to be exactly the same as the sine. I think you guys have gotten pretty comfortable with that by now. Now for tangent, we know tangent is, let's see, tangent of theta is sine of theta over cosine of theta. Well, the sine of theta, well, in this case 30 degrees, is a half, and the cosine of theta, or of 30 degrees, is square root of 3 over 2. So this is going to equal 1 over the square root of 3, which, if you multiply by the square root of 3 over the square root of 3, you're going to get the square root of 3 over 3. And so that's the tangent of 30 degrees. And so we know that that will be the cotangent of 60 degrees. Now, if you find the tangent of 45 degrees, it's this over this. Well, they're the same, so we're just going to get 1. And the reciprocal of 1 is 1. What about 60 degrees? So the tangent of 60 degrees is sine, which is the square root of 3 over 2, over cosine, which is 1/2. It's going to be the square root of 3 over 1, or just the square root of 3. And we know that the tangent of 60 degrees will equal the cotangent of 30 degrees, again using the cofunction identity. Secant, that's going to be 1 over cosine. So it's going to be 2 over the square root of 3. We've got to rationalize our denominator. We get 2 square roots of 3 over 3. So we know that that will be the cosecant of 60 degrees. For 45 degrees, we've got, notice, square root of 2 over 2. Before it was rationalized, it's 1 over the square root of 2. When you flip that, you get square root of 2 over 1. And so this is going to be the square root of 2. And similarly, since cosine has the same value when you, or I should say sine, when you flip that, you're also going to get the square root of 2. And we're down to our last one for 60 degrees. Let's see, it's going to be the secant is the reciprocal of cosine, and so this will be 2. And so if the secant of 60 degrees is 2, then the cosecant of 30 degrees will also be 2. All right, so there's your table, and it's not a bad way to start. Certainly the test 2, that was a good way to start before you did all the other problems. But again, we're leading to the unit circle, and that's going to be kind of the gold standard when it comes to doing things with your trig ratios. All right, so in section 3.1, we talked about radians. So some of you may or may not be comfortable with radians. You don't want to have to take, like 60 degrees and be multiplying by pi over 180 degrees. I mean, you don't want to have to be doing those types of conversions all the time. You really want to get to know your pi radians, or your different measures that are in radians. So let me show you an easy way to see these and to learn these. So I start with my pi over 6 multiples. So you have pi over 6, or 1 pi over 6. If you go another 32 degrees, you're at 2 pi over 6. Notice that's still pi over 3. That's pi over 3. If you do another pi over 6, that's 3 pi over 6. And so now you're at pi over 2. Another 30 degrees, you're at 4 pi over 6. Notice we call that 2 pi over 3. If we go another 30 degrees, we're at 5 pi over 6. And another 30 degrees puts us at 6 pi over 6, which notice that is pi. You go another 30 degrees, you're at 7 pi over 6. Another 30 degrees, you're at 4, let's see, that would be 8 pi over 6. Notice that does reduce to 4 pi over 3. And let's see, if we go another 30 degrees, we're at 9 pi over 6, which does reduce to 3 pi over 2. Whoops, you can't see my 9 pi over 6. It's a little bit below there. If you go another 30 degrees, now you're at 10 pi over 6. Notice that's 5 pi over 3. Another 30 degrees, you're at 11 pi over 6. And then finally, 12 pi over 6, you're back to 0 or 2 pi. All right. So notice really the only ones that have a denominator of pi over 6, we have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So those are really the ones that you got to get to know, but you can get comfortable with those if you get used to your multiples of pi over 6, and eventually you won't need to do what I just did there, but little by little you'll learn them. Let's look at the multiples of pi over 4 next. So we have pi over 4, or 1 pi over 4, and then we have 2 pi over 4. Notice that's pi over 2. 3 pi over 4, that's here. Another 45 degrees, we're at 4 pi over 4, which is pi. Another 45 degrees, and we're at 5 pi over 4. Another 45 degrees, we're at 6 pi over 4. Notice that is 3 pi over 2. Another pi over 4, and or another 45 degrees, and we're at 7 pi over 4, and then finally 8 pi over 4, that's 2 pi, so we've gone all the way around. So notice here we have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right, let's look at our multiples of pi over 3. So that's basically 60 degrees. We go another 60 degrees, we're at 2 pi over 3. Another 60 degrees, we're at 3 pi over 3, or pi. Another 60 degrees, we're at 4 pi over 3. Another 60 degrees, we're at 5 pi over 3. Another 60 degrees, we're at 6 pi over 3. Or back to 2 pi or 0. All right. Now I just want to mention, of course, here we're at 0. A quarter around, that's pi over 2. So I guess our multiples of pi over 2 start at pi over 2. Then 2 pi over 2, which is pi. And then we have 3 pi over 2. And then 4 pi over 2. Of course, our multiples of pi, we're at pi. And then we're at 2 pi. All right, so I hope, let's see, for pi over 2, we had pi over 2 and 3 pi over 2. We've got pi. I forgot to circle our multiples of pi over 3. And so these are the ones that with a little bit of practice you'll get to know quite well, and you won't find yourself having to do conversions, although that's always something you can fall back to. All right. I'm going to go ahead and stop here, and I'll do a separate video for the unit circle.